We live?
Do you hear me now?
Perfect. Good day, everyone. Thanks for
Hello?
coming to our hackathon. I'm Sergey Ajelbekov. I'm one of
Hello?
the founders of the Swiss AI Association. Today, we're doing the second session, the speaker session of our Sustainable AI Hackathon in cooperation with New Wave DLL. And I would like to introduce the agenda for today. So soon, in a few minutes, we will have a presentation by Professor PhD Mustafa Jarar. So Mr. Jarar is a professor of artificial intelligence and chair in computer science of the Birzeit University in Palestine. Professor Jarar will talk about natural language understanding tasks. After Professor Jarar, there will be Denise Avdonin from AWS, our partner for this hackathon. Denise will give an overview of the AWS sustainability approach. After Denise's presentation, we're going to have another speaker, Evgenia Sukhodolskaya from a company called Taloka.ai. She's going to talk about how to boost your AI with quality data. And last but not least, we're going to have Adrian Banahovic and Matthias Asperg from Deep Learning Labs. They're both AI enthusiasts and founders, co-founders of numerous projects. They're going to talk about GPT-3 introduction and practice, DALE, so DALI 2. Yeah. Have a great time, guys. So, Professor Jarar, the stage is yours. Google, please let us know
Yeah,
when
hi.
Professor
Do you hear me
Gerard
now?
is able to speak.
Do you hear me? Hello? Okay. So thank you very much for inviting me to this talk. I'm very actually excited to talk to programmers also, not only researchers, about AI and natural language processing. And I am Mustafa Jarrar from Birzeit University in Palestine. I do research on semantic web, knowledge graphs, but mainly on natural language understanding more than processing. So I will focus on this talk on new trends in natural language understanding. Okay, so in my with my team, my research team, we developed several things. We developed the lexicographic database, about 150 dictionaries, multilingual. We collected them, we typed them over many years. We put them in a normalized database, we linked them together, and so on. We also built the called formal Arabic word net. Word net is something actually important for natural language understanding. We also annotate corpora, morphological annotations. We develop several types of corpora for chatbots, for named entity recognition, and so on. And we are working on some tasks like word sense disambiguation, in which we get 84 percent F score, and also with nested named entity recognition, in which we get 88.4. So I will present basically these two tasks quickly in this talk. If you want to access our lexicographic database, you can just scan this QR. It's rich, it's full of sensets, translation pairs, definitions, semantic relationships, and so on. And if you want to also reach the ontology, which is a tree of concepts, you can also scan this QR code to go directly. The ontology, by the way, is linked with wiki data knowledge graph. Okay, so quickly also to show you how we deal with dialects in Arabic. well, maybe in also in other languages, we have a problem where we have the standard Arabic that we study in the school, or when you hear and use in the TV, the official language. But people in the street or in social media, they write another language. Well, not completely different language, but it's called dialect. And in order for computers to understand the dialects and to be able to process them, so we have to collect huge amounts of text and go to everywhere and annotate the prefixes, stem, suffixes, POS tag, gender, number, and so on for every word. Uh, okay, so now let me show you two things. One is named entity recognition, and the other one later I will show you WSD. With named entity recognition, uh, I'm sure maybe, well, I will show you some examples, but I will show you these two tasks separate with demo, by the way. I will show you a demo. So if you know, Sammy works at Jimmy Carter Center. So Sammy is a person. So this is annotated as a person. Works is called outside, at outside. So it's not entity. Jimmy Carter Center is an name of an organization. Name of an organization. So we need a program to parse, text, extract named entities, whether it is a person or organization or location or something else. This is mature in natural language processing. So really mature. What is new in natural language processing in the recent few years is people start to say, well, the Jimmy Carter is also a person. So I want also to recognize Jimmy Carter as a person. But Jimmy Carter is actually is nested, is part of another name, which is the Jimmy Carter Center. Now, this is partial, or recently people start to do this for most languages. We solve it in Arabic. We develop a corpus with about 500,000 tokens, and we train BERT, and we get high accuracy, and we support 21 type of classes, person, a group of people, occupations, organizations, geopolitical entities, geographical entities, places, or we call it facilities, events, the date, time, language, website, law, product, cardinal, ordinal, and so on, money and currency, and so on. So 21 type of classes that we supported in different domains. And this is the fine grade accuracy. And this is how it looked like. So we put here Jamiat Birzeit. It's like you are saying Birzeit University in collaboration with Edward Said Foundation. So Edward Said is the name of a person. So you see here, Edward Said is the name of a person that is part of the name of an organization. And this says $5,000. So $5,000 together is money, but dollar is currency, and so on. So this is the first part of my talk. This is called Wujud. I will show you a demo just in a second. But let me switch to another problem to show you problem of what's called word sense disambiguation. What is it? So word sense means meaning. So you have a word. This is all languages like this. What I'm showing in Arabic because we solve it in Arabic, but it's, believe me, in all languages it's exactly the same problem. So you have the term bank means bank of a river, or bank and a financial institution, for example. Table or data structure, or table is a furniture, for example. So we want to know, so you give me a sentence. This is like an Arabic sentence. It says here an eye, the word eyes. So eyes can be eyes as a human, part of a human or animal. Eye can be eye, or eye of London. Eye can be something else, a spy, also called eye, and so on. So we have an eye, eye in Arabic. It has actually nine or actually more meanings. So given this sentence, we want to know which one is this. So we solve it with a 84% accuracy. How do we solve it? Also using pre-trained models. We get a pre-trained model and we fine tune it. So we build the corpus. We build the corpus. What's called definition and example corpus, or gloss context corpus. So we have a definition and we have of example sentence, a context that uses this word with this meaning, with this meaning, and we say true if it's true. But if it's false, that this context, the word in this context does not have this meaning, we say false. And we trained BERT on this, we fine tune it, and we get 84% accuracy. Basically, this is if you want guys to do it, you just need to download maybe, for example, if you want to do it in English, for English, you can download the Arabic, the Princeton WordNet, and you can just try it and you will have a system. And it's actually direct way. In case you want to do it for other languages, so first of all, you have to find a corpus with context and definition examples. And you can generate the true and false labels. Yeah. So you don't need to do it manually. You can just generate them. And that's all. Our library here of resources. So we have more than the things I talked about. All can be visited in this link, and I will switch to show you a demo now. Just a second. I will share screen. Okay, so I assume you see this. So if you put here an example, I will copy this example. By the way, well, I can find an example of. Let me go to website of, for example, PLZ University, just to copy a text in Arabic, just to copy a text. If you put this here and you say near, it will bring you Birzeit as the name of a town, and Palestine is a GBE. This is an event. This is an event. Well, this example does not have nested. So, of course, it does not work in English because we train it in Arabic. Otherwise, I could show you something in English. Okay. So you see here, there is an occupation. There is the name of a person, organization. And this is, again, occupation. This is organization. This is unit, kilogram. This is Lebanon, Iran, Croatia, Syria, Algeria, France, names of countries, doctor, which means an occupation, and so on. So this is an example. So if you want to see the WSD is, it shows now, it takes a while because it uses 3 language models together, and it's a slow CPU machine. But it will give you the definition, the correct definition of every word in this context. Maybe it takes some time. It's strange, but it should be faster. Okay, so exactly. Yushar, it's actually correct. شارك في بطولة, exactly. Fortunately, all of them are correct here. Yeah, all of them. Player, representatives, all of them actually, fortunately, are correct, but not necessarily always to be correct, because it's 84% accuracy. And if you click on this, you go to a node. Look, this is what we call it really nice, because this is not only we show the definition, there is a number of a node in the tree, which means the like our Arabic ontology. It goes to this node exactly on the tree. And okay, I will stop here in case you have questions. Thank you for listening. I hope it was okay.
Thanks, Dr. Gerard. I hope you can hear us.
Okay. Yeah, bye-bye.
So it was a really interesting one. Oop, he's gone. Yeah, I suppose Dr. Gerard is gone, so we should. Yeah, sure. So who is next? Dennis, are you ready to present? Hello. Let's just wait a minute, maybe, till Dennis comes back. Yeah, if not, let's move to Adrian then.
Yes, I am. Yes, yes. Do you see my screen? Yeah. Do you see me now? Great. So, good morning, everyone. I have a pleasure to talk about the real magic of AI. I would like to describe the systems like GPT-3, Codex, and DALI. Um, when I was watching first time the Iron Man and I saw Jarvis, the idea of system like this just formed in my mind. And for me, the systems based on GPT-3, they are like the an alpha version of artificial intelligence which exists in the movies. And my name is Adrian Banachowicz, and I work for New Native Group as a data scientist. Majority of my tasks are focused on GPT-3. This is the most useful tool for me, but my favorite one is DALI. And in DALI, you can write some sentence. For example, futuristic picture of the mouse astronaut, which is eating spaghetti, and it generates for you some images of this sentence. And for this sentence, these are these images, and for me, these are really amazing. I really like it. So at the beginning, I will talk a little about DALI. Then I go to the codex, and I will show you a sandbox, how you can write a code without knowing the JavaScript. And at the end, I will show you the examples which you can use in GPT-3. For now, DALI 2 is a new system from OpenAI. And if you want to use it, you can join by waitlist. And every week, the OpenAI gives 1,000 permissions. So you can try it. And for now, you can try to change parameters like this, some examples, and you can see that it's working really amazing and creates a lot of nice pictures. And for me, the most amazing thing is to adding new stuff into the image. And for example, here we can add flamingo in 3 position and in different variations, or some furnitures like sofa in different style on different positions. So this is really powerful tool for designers, and you don't have to know Photoshop or something like that to create really good photos. Next, I would like to show you the codex and what you can do. What you can do, and for example, like you can see, we have a simple game of the dot, and I will show you how you can write it by your own. And what is amazing, I create this moving dot, and I don't know the JavaScript. The codex do it for me. Okay, so firstly, to create a game like a simple snake is to create to some box frame where our dot will be moving. And for that, we have to just provide some instruction like create the frame at the middle with size 400 pixels. And then we can add some dot like our snake also at the middle. So DALL-E is creating another object for us in a few seconds. And this is a square, but we would like to have some circle, so we can change this dot to circle. And now our dot is our circle. And because this is a game, so we have to have some possibility to move this dot. So we have to just write allow to move the dot. And we have to add some condition that the dot can't go outside of the frame. And now in a few seconds, I add the dot, which is moving inside the frame, and it can go outside the frame. We can change the speed of our dot. Move the dot by 10 pixels. It's a little faster. So now we have to add some food if this is a snake. So create a blue, for example, blue dot randomly inside the frame. And like you can see, we have another dot. So if this is a game, we have to have some points. So we can add just a counter. For example, under the frame. And now the last thing what we have to do is to add the condition that if dot touch blue dot, add to count. And in 7 or 8 instructions, we create a simple game like Snake. And because this is artificial intelligence, and it's sometimes it's working, sometimes it's not working, because this code sometimes isn't excellent. Now it's working perfectly. So our dot is bigger. We have another point, and the blue dot is created randomly inside the frame. So we create a simple game with seven instructions without knowing anything in JavaScript, but we can create a lot of different stuff here. We can create, for example, create some entity for our backend, for example. And this is, for me as a developer, is amazing. I can ask the codecs to write a unit test for, so let's create a lot of stuff here now. And when I tried it yesterday, this was just three unique data, but here is a lot of. But yeah, now I can write some unit test for this car. So in just two instructions, I create a unit test and an entity for backend in my site, and the only thing what I have to do is copy it to my page, and that's all. And of course, you can create some API for that, and this can be your plugin in, for example, in Visual Studio. And so this is a really powerful tool. And at the end, I would like to go to OpenAI to GPT-3, and I will show you what you can do in your projects in your company with this powerful neural network. Please give me a second. Okay, and we are on the playground for GPT-3. And here, this is the most useful tool because you can write whatever you want. You can think that this is your personal Jarvis from Iron Man, and you can, for example, ask him to write a cake recipe. And the GPT-3 creates for you some chocolate cake recipe, but I don't recommend to try it. But this is one of the simple possibilities. You can also, for example, ask GPT-3 to create some story, maybe some recommendation, right? Right. And in a few seconds, you have a recommendation for your friend. You can make a bigger temperature. That means that the GPT-3 will create more different styles of this sentence. And also you can change the maximum length to change how big this text should be. And now we can try to translate this to the Greek. The professor before have a tool which was very similar, but here we can just write translate. And you can connect this GPT-3 with JavaScript or with Python, and you have to only send request to GPT-3, and in response you get your answer. And this answer, you can see that this can be everything. And here we have a translation to Greek from English, our recommendation. Also, the nice stuff is the GPT-3 is able to summarize some text. And for example, we can choose the audience of our text. So for example, we can choose the second grade student, and I will copy some text about Jupiter. and it's create for us some summarize. We can also change it for a kid, and this will be some stuff for a kid. Also, we can create a chatbot, and again, we have just write him just the instruction, and because this is a neural network, it's better if there are some instructions, some examples, so we can add some examples of this chat, and now we can ask some question like what is AI, and Marv will answer for that. No, I will ask. So the answer is the same what before. This is the neural networks that this is not perfect. Yeah. The other powerful tool thing inside this is that you can convert one programming language to another, for example, from JavaScript to Python in one command. And you can also create this as a response and request to GPT-3 by Python, by JavaScript. And one of my favorites is the to ask GPT-3 to convert movies titles into emojis. And for example, here we can some examples, and then we can write Star Wars, and it's create the some emojis of this. We can write so yeah. So there are a lot of possibilities to use GPT-3. You can write everything what you want. There are a lot of examples what you can do exactly with that. There are documentation how you can easily connect this with your systems, because the quick start is really quick. There are some lines. This is more of the code to create something like that. And for me, one of most powerful thing inside this is you can create the classification based only on text. So here I have a prompt from our systems in New Native, where we can check if someone ends the conversation. And here we have some tip, and this is really useful for GPT-3 if there are some tip in classification. And here we have the answer, yes or no. So our message can be thanks for all, goodbye. And should we end the conversation? Yes. So it's can classify the bias of the message. And now I would like to show you our system in New Native, where we're using the GPT-3. And this is, I hope you see, yeah, you see it. And we create a Discord bot based on GPT-3, and we can ask him everything what we want. For example, what is AI? And he will answer for that. Or no. I have to close the some stuff. So like you can see, sorry. Yeah, I have some problems to share again the screen. But the main idea is that we are using the GPT-3 in our Discord board, and it allows us to send some requests to the GPT-3. We had also a possibility to send emails, but by GPT-3, and we're using this classification, which I show you. And what is also amazing that when we want to send an email, we just write bot, can you send an email to Adrian? And bot has unstructured data about us, about our company. And in this unstructured data, it can find by my name my email and send it to me. Also, of course, there are a lot of different functions to make it, but this is one of the tool what we can do with GPT-3. I hope you enjoyed my presentation. Sorry for some issues, which I didn't expect. But yeah, if you have any questions, just let me know.
So great, Adrian. Thanks for your really interesting presentation. I think now we can switch back a bit to the sustainability topic. So Dennis, if you're online, we would really be curious to hear how Amazon is approaching sustainability.
Sure, thank you. Let me start sharing my screen first. Go live. Okay, cool. Right. Can someone confirm that you can see the presentation?
Yes, looks good.
Very good. Okay, good time of the day, everyone. Welcome to the second day of the hackathon. I'm going to talk about how AWS enables its customers on the sustainability topic from different angles, and very briefly touch on AI ML capabilities which AWS provides. For those of you who weren't at the presentation last night, my name is Denis Avdonian. I'm a data analyst consultant with AWS Professional Services, and I work at sustainability specialty practice, where we focus on building sustainability-themed solutions for our customers. So back in 1987, United Nations defined sustainability as meeting the needs of the present without compromising the ability of the future generations to meet their own needs. Very beautiful definition, very simple, very encompassing, and it really reflects kind of the challenge which we're facing, how to enjoy life today, but make sure that our children, grandchildren, great-great-grandchildren can continue enjoying living on this planet. And to support this objective, UN defined 17 development goals. And you can see that it covers all aspects of our lives. And when organizations start to approach or already approaching sustainability as part of their business, they focus on reducing emissions from their operations, optimizing water usage, minimizing waste through reuse and recycle, and ensuring that employees are treated well, not only in the organization itself, but along the entire supply chain which our organization is part of. And speaking specifically about carbon emissions or greenhouse emissions, there are a number of reporting and accounting frameworks, and they all can convert various emissions which are produced into CO2 equivalent. So common currency for emissions is known as CO2 equivalent. And these reports divide emissions into different scopes. So emissions produced by organization itself in the course of its operations fall into scope 1. And this may be from facilities which the company has. Say if a company manufactures some products and they have factories, that would be scope 1 emissions. Then energy, heating, and cooling which they purchase from utility providers fall into scope 2. And then scope 3 is the most broad one because it covers everything which happens upstream and downstream from company itself. So for example, again, if a company manufactures something, they need materials for that. So they buy them from suppliers who in turn need to construct them from raw materials. And this all generates emissions. They need to be transported, employees commute to work. And then once the product is produced and sold to customers, then again, it needs to be transported, sales activities generate emissions, and eventually product is used and goes out of life and needs to be disposed of. So organizations which want or have to report on their CO2 emissions need to consider this entire value chain and estimate or calculate emissions along it. And well, I don't need to convince you about importance of sustainability, considering that you came to a sustainability themed hackathon. But I guess we all agree that this topic has been accelerating in the recent years, and there's more and more demand coming from all directions. There is a lot of government regulations which steering various industries into decarbonizing and reducing emissions, or using water more sustainably, or employing kind of better governance to ensure fair treatment of employees and suppliers, etc. Rock spoke yesterday about ESG and investing, and shareholders and investors have become more and more conscious about what type of businesses they invest into and what they own, because if sustainability topics are not addressed, the business may not exist in a few years. And Accenture did a study about a year ago where they demonstrated that companies which embrace digitalization and also sustainability are about 2.5 times more likely to outperform their peers who don't. So many companies have been focusing on digitalization in the recent years and automating their business processes and creating different digital services for their customers. But companies who also embrace sustainability are going to be here for longer and they will perform better. So how does AWS help its customers to address topics of sustainability? We look at it in 3 ways. First of all, sustainability of the cloud, meaning that if you migrate or if an organization migrates workloads to the cloud, they realize sustainability benefits immediately, because the infrastructure which is provided by AWS is much more efficient than an average on-premise data center, and it's also much better utilized, and I'm going to talk about it in more detail in a minute. The second angle is optimizing workloads or solutions in the cloud. So after migration, or if you build a new solution in the cloud, we have best practices and tools how to help customers build the solutions in a sustainable way, optimize them. And finally, last one is transformation or sustainability through cloud. This is where we help customers to build solutions which address sustainability topics, and I'm going to talk about how we do this towards the end of the presentation. So focusing on the first one, sustainability of the cloud, 451 research shown that AWS data centers and infrastructure is considerably more efficient than an average data center which they surveyed. You can see here in Europe, it's almost 5 times or about 5 times more energy efficient than doing it on premise. The same was found in Asia Pacific, and in the US, the ratio is slightly lower, but still very significant. So if we focus on Europe, kind of findings of this study, I'm sorry, I think someone is not on mute and there's background noise. I'm not sure if it goes on stream as well, but can you please go on mute? So if we focus on Europe, about two-thirds
still.
About two-thirds of efficiency is due to the efficiency of the servers and the data centers themselves. Sorry, two-thirds is due to efficiency of the servers and high utilization of these servers, but about 13% is due to efficiency of the data centers. Data centers is the core business of AWS, so they were built with efficiency in mind from the beginning. And we also use a lot of renewable energy, and there is an objective to get to 100% renewable energy by 2025, which is only less than 3 years away now. And once this happens, then additional efficiency will be realized, so up to 96% in comparison to an average data center. And this survey was done in Europe across 308 enterprises in France, Germany, Spain, Ireland, Sweden, and a few other countries across a variety of industries. So it's quite representative. AWS is also part of the data center industry in Europe alliance known as Climate Neutral Data Center Pact. We joined it back last year in 2021, and it establishes a self-regulatory initiative which was developed in cooperation with the European Commission. And the objective here is for organizations which have data centers to prove efficiency with measurable targets. It's self-regulatory, so there are no industry or government-imposed targets, but each organization defines them, or as part of this data center pact, they do it, and then they have to demonstrate that they're working towards this targets. Another aspect is purchasing 100% renewable energy and prioritizing water conservation, reusing and repairing servers, prolonging their life, and looking for ways to recycle heat. Another aspect is that global infrastructure, which is built by AWS, it's proprietary hardware, and it includes purpose-built servers, routers, processors, which are optimized for workloads which customers run on AWS. As an example, we improved power efficiency and availability by removing central uninterrupted power supplies in our data centers, because traditionally it's kind of centralized. But in AWS, instead of doing this, we put power packs and battery packs and custom power supplies directly into the server racks. And as a result, energy conversion loss was reduced by 35%, because the closer you have your energy source to the consumer, the less energy you lose in transit. Another example is how we built hardware with sustainability in mind is our Graviton 3 ARM processors. It's the latest generation of them, and the servers which run on these processors are about 6% less and consume about 6% less energy than similar instances run on other processors. And we also built custom processors for machine learning. Inferentia is a purpose-built processor for inference, and it's very energy efficient. It was built kind of with this in mind. We also have a purpose-built processor called Trainium for training, but by its nature, it consumes more energy because training is very computationally expensive. Right. So the second pillar is how you optimize your workloads in the cloud, or how you build them with sustainability in mind in the first place. So at AWS, we have a well-architected framework which guides customers in building solutions with best practices in mind. So they're secure, they're reliable, they perform well, they are cost efficient, and it's easy to maintain and operate them. And last year we added sustainability pillar to this framework, which helps organizations kind of approach it in a systematic way. So to build sustainable solutions in the cloud, you need to quantify the impact of your workloads, and then you can manage it, and there are best practices how you can do it. So to make it real, kind of practical for you from machine learning point of view, what you can do is when you're choosing an algorithm for a particular use case, you don't always have to use a very complex one. So depending on your business objectives, you can use a simple algorithm which takes less time to train and consumes less energy as a result. And from business point of view, the results will be good enough to be put into production. As data scientists, we kind of often perfectionists. We want to squeeze this last performance out of the model, make it even better. But in reality, very often this is not required, and you can use a less complex one. Or you can employ techniques like transfer learning or incremental training, so you don't train your models from scratch every time. You can take a pre-trained model and extend it, or you can take a previously trained model and kind of refine it with new data. Another tip would be to use serverless whenever possible. So AWS has a lot of serverless services, like Lambda functions, like Glue jobs for data processing. We have Hadoop EMR clusters, which are serverless now. Data warehouses on Redshift, which are serverless databases. So there's been a lot of effort put into building serverless services. And of course, there is a server behind it, but you, as a developer or machine learning expert, you don't need to worry about it. It's all managed in the background by AWS. And the beauty of it is that as soon as you is your workload finished, this capacity is released to other customers, and this is how we achieve high utilization and efficiency. Then simple things like forgetting to switch off notebooks at the end of the day, and they sit there doing nothing but consuming energy during the night. You can configure lifecycle configurations to shut idle resources down. And in machine learning, we use a lot of data, right, for training and also for preparing results for inference. So be mindful about what data storage options you use, what compression algorithms you use, because with large volumes of data, even if you achieve 10% efficiency in compression by using a different algorithm, that will result in huge storage savings and hence energy savings and other environmental impacts. It's a very broad topic. There are lots and lots of different aspects you may want to consider. So my colleagues wrote a series of blog posts called Optimize AML Workloads for Sustainability. So I encourage you to go and check it out. Also, this month we run a series on sustainability, specifically advising customers how to optimize workloads for sustainability on our Twitch channel. So tune in on twitch.tv/AWS every Monday this month at 8 p.m. Central European time, and or you can go and watch recordings afterwards. Another tool we have for customer, which was introduced last year, is customer carbon footprint tool, and this is available in AWS console along with cost summaries and forecasts. We now provide CO2 equivalent impact and forecast, so you can see how your workloads generate emissions over time, and you can also see prediction into the future. You can drill into what services generate this impact, so you can understand where you need to optimize. Finally, transforming businesses for sustainability and solving sustainability use cases. This is where probably most impact kind of in the medium to long term can be generated. And this all starts with data, because before you can manage anything, you need to measure it. Plus, for sustainability use case, you may need to use additional data, which is not only generated by the organization, but third-party data, which may complement it and enhance the use case. And kind of this hackathon goes in that direction as well, as to use publicly available data together with maybe third-party data to address different challenges. So we have at AWS a number of data initiatives. There's Open Data Program, where we host a lot of high-value cloud-optimized data sets, and we work with different data providers to make data publicly available. Then there's a specific initiative to address sustainability topics, Amazon Sustainability Data Initiative, and then there is a data exchange where organizations can share data with a license attached to them. So it's effectively a data marketplace, where the open data and sustainability data initiative are completely free for the data consumers. Data exchange also has some free data sets, but the main purpose is for commercial organizations to sell their data. And in terms of what SDI provides, this initiative works with scientific organizations like National Oceanic and Atmospheric Administration, for example, or NASA, and various meteorological organizations to host their data sets on AWS Cloud. And this may include weather observations, weather forecast, air quality, climate projections data, so lots and lots of sustainability-related data sets. And it helps data providers to share them because they create those data sets to inform public and enable research, but it also makes it very easy for consumers of the data to use it because it's readily available. You don't need to download it, to store it, to prepare it. It's there for you to use right away. As part of ASDI, we also working with we support sustainability-related research by various organizations. So, for example, we collaborate with Silverline and the National Center for Atmospheric Research to address the need for infrastructure for research which they're doing, because they're doing a lot of computational research, and that's requires a lot of compute power. This program enables implementation of one of the most sophisticated global climate simulation models. And once they do the simulations, this data is made available again through AWS Open Data Program, so it can be used further by other organizations. So I already spoke about data exchange. It has quite a few free data sets or sample data sets which you can explore before deciding whether you want to subscribe for the full data set with a license. And there are also a lot of sustainability related data there, especially ESG data created by various agencies, since they put effort into collecting and aggregating it. They charge a fee. But there's also a lot of open data from various government organizations and agencies. Okay, so finally, let me quickly talk about solutions which we build for the customers, so together with the customers. So as I mentioned in the beginning, I work as part of sustainability specialty practice in professional services, and we engage with customers on various topics. Sustainability in general is relatively new for organizations. Some industries have been addressing it for a number of years already, but some only starting now. And very often they don't know where to start. As part of my team, we have both technologists like myself, data analytics specialists, or application architects, or data scientists, and other technical professions. But we also have quite a few sustainability experts, so people who understand how to calculate carbon emissions, all these various reporting and accounting frameworks, or how to manage buildings, how to build efficient data centers, and how to manage supply chain end-to-end, and waste management, etc. So those subject matter experts work with our customers to help them devise sustainability strategy and define how they're going to transform their business with sustainability in mind. And we also build quite a few package solutions which can be quickly deployed and enhanced and tailored for specific customer needs. So carbon footprint framework is one example, because many organizations calculating their carbon footprint, as I was explaining in the beginning. Remember, scope 1, 2, and 3 type of emissions. So we have a reporting framework for that, where organizations can describe their business process and then upload data about activities they perform as part of the business. And this is all calculated into CO2 equivalent, and then reports generated, dashboards, so organizations can understand where the most of impact is happening and start managing it. Another big initiative or offering which we have is sustainable building management. So I think about 9 or 10% of all carbon emissions are due to real estate and office buildings, at least in the US. I'm not sure if it applies worldwide, but at least in the US. And we have solutions which help organizations to collect data using IoT from ventilation systems, air conditioning systems, thermostats, but also energy consumptions within buildings, and kind of aggregate this data and give them insights into how they can optimize it again. One of our large customers, as you can imagine, is Amazon.com, so the retail part of the business, and we're working very closely with them to optimize facilities use around the world as one of the examples. But we also work with other companies. Sustainable packaging. Again, Amazon is a perfect example here because in the last few years there's been a lot of push to reduce it, and the packaging has been improved, and both in weight and size, and as a result, we're saving equivalent of billions of packages. Amazon is always a good example to quote because at the scale of the business, even small improvements make tremendous impact. Okay, so last slide. I wanted to give you at least a high-level overview of AI ML stack, which AWS provides to the customer, so to motivate you go and explore it in more detail. So if we start from the bottom, we have built purpose hardware for AI ML. I mentioned Trainium and Inferentia, kind of machine learning processors, but we also have a lot of other CPU and GPU instances. I think there are more than 400 different types of virtual servers, so you even can get bare metal physical servers if your use case really requires that. So it all starts with very efficient purpose-built infrastructure. But we also provide all kind of modern frameworks which can be used for machine learning, for training your models like PyTorch or TensorFlow, etc. And we have special kind of services for inference. So you can optimize how your workloads scale in production. Then at the next level of the stack, there are services which are aimed at data scientists and developers, data engineers and application developers. And there is a range of the service there. There's no-code tools like SageMaker Canvas, which is aimed more at business analysts. It's drag and drop. You can construct ML pipelines there. It uses AutoML in the background to train models automatically. You saw a presentation I gave yesterday about Studio Lab, which is aimed at people who want to learn about ML, or at events like this hackathon, for example. And then there is a broad set of services under Amazon SageMaker umbrella, which you can use to prepare data, do feature engineering, train your models, tune hyperparameters, tune your models in general, and then deploy them into production, expose them as APIs, or integrate in other ways into your applications so they become part of your business operations. Because one of the challenges which many organizations face is that they experiment, they build prototypes, they demonstrate the value of ML, but then they struggle to embed it into production. We built Stack, which enables all stages of this journey. If you use kind of SageMaker Studio and end-to-end service, then it's very easy to roll trained models into production, then monitor them and retrain, etc. And then at the top, you can see there is a very broad spectrum of AI services which address the different areas, like NLP, for example. We have services for translating from one language to another, or to extract text information from documents of various nature, or to construct documents, or speech recognition and converting text to speech as well. There are also kind of hardware and software services for industries. Say if a company has a large factory and with lots of equipment which was manufactured decades ago, it's very difficult to instrument such equipment and understand what is happening. So we developed a service where you can buy IoT sensors and just attach them to different equipment, and those sensors collect vibration metrics, temperature metrics, and others, and transfer them back to the service, which monitors for anomalies and kind of recommends when maintenance may be performed, etc. So yeah, I can talk for a long time about different services. They very broad and cover a lot of different use cases. So I encourage you to spend time learning about it, about the possibilities, because then you can build solutions really quickly by employing them rather than doing everything from scratch. Thank you very much. I hope that was interesting and informative for you. If you would like to learn more about sustainability and ML, you can go to aws.amazon.com/sustainability or ml.aws, and you'll find a lot of interesting materials there. And also feel free to reach out to me directly if you have any questions or feedback. Thank you, and good luck for the rest of the hackathon.
Thank you very much, Dennis. That was really insightful and, of course, quite overwhelming, I think, for normal people who don't use AWS on everyday basis. I'm sure we can share some information from your presentation later at the hackathon in our channels as well. But as next, I would like to invite Evgenia from company Toloka, who is dealing with data and managing data and one of the major inputs to any good ML or deep learning model, of course, is data. And Evgenia will present us how to deal with that and how to do it efficiently and maybe sustainably. So, Evgenia, please, the stage is yours.
Yes, thank you, Rock. Let me try to share everything, which might take a second, but I will do it. Okay. Okay, give me a second. It was very successful in the other chat. But now, as it always happens in the presentations, nothing is successful. Yeah, give me a second again. Okay, will it? Nope. Yeah, you definitely did. The problem is that can you see the more presentation?
Now it's good.
Oh yeah, perfection. I managed to do it. I'm this one struggling person with M1 processor. Okay, so as you see it, let me finally start. Okay, so I am talking today about as you said, the sustainability, not in that way, but mostly about the general approach about using the data. And this is a very, I would say, like high announced topic, boost your AI with quality data, but I will try to simplify it more and make it less, like, I don't know, unapproachable. and mostly just talk like in a smoothie presenting, just explain a little bit how you can approach the data. So yeah, I am from Toloka. Toloka is a crowdsourcing platform, and what does it mean? I will explain a little bit further. And I'm here a data evangelist, but I guess I am more close to ML crowd because I've been an ML engineer for some time, also data analyst and software developer. So I would say like I've observed the problem of the data and ML AI from all the sides. So I would say like, let's say I can speak here on this topic. So what is the agenda? I will try to maybe give a small review why we have even a data challenge in AI, and do we have it, or maybe we don't, but I would say we do, and how it might be approached with crowdsourcing as one of the ways of solving it. And I will try to give a little bit of examples how it can be used, so not to present something in vacuum, but actually give a tool which could help you with data solving, data gathering, data labeling, and data accessing in AI. So usually AI solutions require high quality data. What do I mean? When you see an ML problem, your first thought is like, okay, now I will create a perfect model which will access everything, which will be very smart, very math related, and it will solve like all of the problems. Sometimes AI is very hyped up because people are like, okay, reinforcement learning, self-service, like everything, machine learning does it for us. AI is so close. And yeah, kind of in a way, that's like this. But when you approach any problem, you need a human labeled data. When, for example, we have recently COVID, and sadly it's still there. And when the COVID arose, there induced a new problem: how to detect it, how to fastly exchange the information about the viruses, how we can detect by the scans of the lungs that it's actually COVID or like pneumonia related, and etc. We have moderation of the content, which actually happens every day at the internet, at the advertising industry, at the chats. And it's also kind of always related like to this mechanism. You require some human labeled data. You have self-driving cars. Self-driving car is an amazing technology, but how it started, you have like information from the cameras, which is recorded, and you need to understand what is like in between you. Is it like a stop sign, a go sign, a pedestrian? Also, we need to gather it from somewhere. So yeah, and the context in the world changes every day, and your ML learning model, while learning, should somehow induce these changes, use them, like take this context and apply it to the algorithms, to your solutions. So yeah, usually ML model kind of still as good as your training data, because all the information it gathers from the data. And here is the question: how much of the data we need? Okay, like maybe 10 items, maybe 100. Yeah, sometimes if you're using solution, when you're like, for example, taking a very famous network which was like trained on the millions of data, you can cut away its head, you can like train on your small examples, and boom, you have a perfect solutions. But usually you require like a huge amount of data to approach a new problem, really huge. And here we have a little bit of the problem of, I would say, lack of knowledge in the data domain. Usually AI is built on the 3 pillars. It's hardware, which everybody like can understand why we need it. We need GPUs, we need everything, we need train our models. We need algorithms, and algorithms are also, this is a huge like interest in the field, that the new architectures, new networks, everything, and we need data. And when it comes to where we can like approach each of the pillars, for the first 2, hardware and algorithm, you always know like an answer. Hardware, yeah, AWS, Dennis previously explained. Yeah, they have a huge resources and everybody knows that. Algorithms. from keras import layers, like the common scientist joke. Everybody, like even the guys who are not in the field that much, have heard of a TensorFlow or PyTorch or other like frameworks when you can approach your problem and start solving it algorithmic wise. When it comes to data, people are like, internet? Maybe, yeah. There are some open data sets, like for example in Kaggle, you're like having a data set, then you start solving it. But in the real world, data is kind of not lying on this perfect plate with the blue collar. You're kind of not really knowing where to gather, how to get it, and even if you're getting data from some outward, how you can prove that it's kind of quality, high quality, how to use it. And there are several ways to approach it. And one of them is crowdsourcing. And usually, actually, even if the crowdsourcing is here for already 20, 30 years, and even more actually, the concept is so well known that I would say it's with us for 1,000 years, people usually don't know what is that and who uses that. I was recently on a very interesting, very AI conference in Amsterdam, and I was like attending different booths. I was talking about data science. That was very interesting and perfect. But the problem was, I was like, okay, guys, and how you gather data? Have you ever heard of crowdsourcing? They're like, no. And I'm like, do you know like Amazon Mechanical Turk or something? People are like, no. And I'm like, whoa. So let me introduce you to this approach, because it actually is very working and time-proof, time-tested, but still is not very known. So I would say it will skyrocket like right now, when our ML algorithms are at that stage that they are really perfect, they're really complicated, and we have hardware, we have everything, but we still have problems with data. So what is crowdsourcing? The concept is very simple. You have a huge task. It is very hard. Let's like say it's like pretty hard. You don't know, you want to train a voice assistant. Voice assistant is basically a speaking human being. It's like teaching a child from the beginning how to answer questions, how to search for facts, how to react on your voice, how to process your speech, everything. And you need to train it. And you can't imagine a task for gathering the data like gather me audios of correct responses to a voice assistant. That's pretty much not understandable. What is this? So the focus of crowdsourcing is to simplify the task and scale it. So you have a huge task. You decompose it in a small particles. For example, you need to gather 5,000 amazingly labeled images. You create one simple task. Gather me an image and label if there is a car, for example. Select a polygon. So you have these particles, you distribute them all over some crowd which is gathered in one place, for example, a crowdsourcing platform of any case. Then the labeling or the gathering process is performed, and you have a lot of particles of the raw data. And then using some aggregation techniques, which are usually provided as a tools, because they're like well known from some science experiments, etc., like from good practices, you combine back the result, which is actually the answer for your huge task. And here you start thinking, but why? Why do I need let's better hire an expert. For example, I have my company, I have money, I have budget, I have a task. Let's gather some experts. They will actually know how to approach this hard task from the beginning. I don't want to do this dissolving of the particles and understanding what crowdsourcing is and why do I even need that. I just want to train my models for fun, do my fine tuning, and I don't know, like approach ICML, present there, and be very happy. Here comes the problem. Usually experts are really great at like marking up your data and everything, but they're expensive. I mean, sometimes it's okay, sometimes it's not. You hire an expert, you have a contract, everything you need to pay like a good money. It's kind of unmeasurable because expert is like basically, you know that expert is performing very good, but how good? Maybe he is performing 95% quality on your data because humans are perfect Exactly. And you need 99 because you work in the medical, I don't know, field. And in the medical sphere, every mistake induced by AI or in jurisdiction or somewhere else, it might be crucial. And it's hard to scale. Okay, one day you're perfectly good with your experts and you're gathering data. Next day you wanna like scale it up and create an online working model which process like, I don't know, thousands of data every millisecond. And you need more training data and you need more evaluation and you need model monitoring every second. And you don't have people, you have your experts who are working like 40 hours per week, okay, maybe 50, which is not very welcome, I would say, in the working atmosphere. But it's not enough. And here comes crowdsourcing, which is it's like a tool that you need to master, but after that, it becomes very scalable. And it's pretty economical also. Why I really love to give this example, but sometimes I'm just like, since I've done a lot of projects on crowdsourcing, because I've also did like a lot of technical assignments and used them for training ML models, I'm usually asking like, can you imagine how much it costs to label one picture? And people are, I don't know, like maybe $1. And I'm saying, no, it's like 1/10 of a cent. And usually it creates a reaction like, how? Oh my God, who will do that? And yeah, they will, because with the right tooling and with the right managing of the crowd, it becomes so scalable that the prices are just adjusted to the algorithmic conception of the crowdsourcing and managing the crowd as, I would say, as an instrument. So at this point, when you master the crowdsourcing, you start using it at different scale. It's like a framework. It's like a framework you're using, for example, TensorFlow, and you're importing some modules and you're stacking them, you're creating your neural network, and it works. So you're designing a pipeline, you're designing your model, you're designing how it will outcome with the results. The same works with crowdsourcing. You're just designing what do you want to get out, how you want to aggregate data, what quality do you want, what particular filters you're interested in for the crowd that's working on your tasks, but you're not managing the people. Because people can be seen as the cluster, as a computing cluster. And it's pretty impressive, yeah? So these three pillars of data are aligning in some sense because they're aligning in the means that you're working with the three computing clusters, the GPUs, the TensorFlow, and the computing cluster of the people. And how you can compute it, like, it sounds kind of strange, yeah? Like, what do you mean managing the crowd as a cluster? I don't know, like, kind of strange. Can I be managed as a cluster? But yeah, basically you have these 4 steps, how it works. So you're coming to a crowdsourcing space, crowdsourcing like framework. You're designing your task, you're designing the project that you want to work on. It can be very different because the people, they're usually very well working with the different types of data, like audio, video, images, text, everything. So you can approach any problem. You can choose the language because the crowdsourcing usually uses crowd all over the world. So you don't have a limit, for example, for the language knowledge. You can decide for testing some of your ideas. You can decide which devices this crowd will use or like how qualified they will be. Then, after choosing the crowd, you can train it. Train not in the meaning of the machine learning model. It's not like, okay, so I need to gather data for training machine learning model, and I need to gather data to train the how to gather data. No. Here we have a focus, and this, I would say it's like a magic trick. Magic trick is that the people are already very proficient in a lot of things, which can be used for gathering data. We are very good at classifying by nature because we were trained from childhood for that. We're very good at creating like translation, speech to text, text to speech, object recognition, etc., etc. But you need like just explain a little bit what is the result that you're willing to get from the crowd. Then you can control the quality of the data that you're getting. You're getting thousands of images or you're getting thousands of audio recordings. or something like this, but you want to, for example, some certain quality, you always need to balance quality and speed, as in machine learning. Here, there are several, I would say, close to science techniques created in crowdsourcing, which are based, for example, the expectation maximization algorithm or some Bayesian statistics for controlling the quality of the crowd, measuring their knowledge in some certain tasks, and then aggregating this knowledge and using the most reliable answers to create a high quality data. And then you just can share this knowledge. It's like for delivering high quality results, you can just gather this knowledge of different projects used by different people through the time and somehow find these patterns which you can apply in general for the tasks like this. So, to not talk about something in vacuum, I want to show you how some of the problems actually can be approached and moreover were approached using crowdsourcing. And as an overview, I would say here is not even all, but how you can use crowdsourcing. You can use it differently. You can use it for voice assistants. You can use it for model monitoring of the voice assistants, giving some sample of the voice assistants' work and labeling it through the crowdsourcing. You can create speech-to-text tasks, vice versa. You can use it for search relevance problems or moderation of the content, which is pretty much crucial because, for example, in the world of advertising and moderation of the content, everything changes very fastly. And sentimental analysis must be performed basically every day, and this requires the attention of the crowd. Moreover, why it's actually, I would say, like killing two birds with one stone, it's like you're also can use a crowdsourcing as testing your product in some way as on the final users of your product, because basically the crowd which is there is the same crowd that uses your solutions in the production. So not only you can, for example, check how relevant is your search results, you also can actually check it on people who will see these search results. So let's start with the search relevance, as I was talking about this. What is actually a search relevance? Search relevance is when you're coming to any search engine and you're want to find something, you have some search query, and there are some ranking outputted results, and how relevant they are to your search query is actually a really, really important thing, because if they're irrelevant, you would be at least unsatisfied, I would say. So in this problem of the search relevance, you actually very, very much scared to give mistakes. For example, you need to update a model, you need to create a new ranking. You have 3 versions of a model, but testing them in production might be very scary because the unsatisfactions of the users in this particular setting might be crucial. So here you can use crowdsourcing as a, I would say, instrument for A/B testing. So you're just creating a project, 3 projects. For example, you have 3 models, you have 3 projects, and you're creating an offline evaluation of your new feature. You're designing 3 projects in which you're induce your data in a very fast time. Crowdsourcing is very fast. You see your results. So it's 1 to 3. And then after seeing the results of the offline evaluation, you can proceed to online one. And then the solution chosen by the combination on offline, online evaluation and A/B testing, thanks to crowdsourcing, would be less harmful because you tested everything on the crowd, but you're not losing your users. So that's one of the approaches, I would say, not even of the ML monitoring, but more about the model testing with the crowdsourcing, because you can even induce it in your pipeline. Crowdsourcing has usually platform and API, which you can use in the different setting. For example, Toloka is integrated with Prefect, so you're just creating a directed acyclic graph and you're using your models, you're sending the information to them, to the projects are getting labeled, you have received some answers which tell you the quality of your models, and after that you can like introduce the new model to a production. Then the case which is like particularly interesting, because as I was talking about the self-driving cars, it's a really important matter of the quality there. I am like one of the favorite topics, it's actually an adversarial attacks, because they are very critical for self-driving cars. For ones who doesn't know what is that, like imagine you have a picture of a stop sign, then some random noise added to it, and boom, your car by some, I don't know, changing in the ML model, it's not robustly trained, and ML model starts classifying the stop sign as a go at 60 kilometer per mile, I don't know, or 60 kilometers speed. And that's dangerous. That's definitely dangerous. So crowdsourcing is actually very good at the model monitoring at that one, because crowdsourcing is very good with working with adversarial attacks. We as humans still see a stop sign, for example. And this monitoring can actually help you to detect that there is something not right with your model working at this time. And so here was an example of the segmentation done for self-driving cars. Segmentation you need to do to understand what is it around the car, because usually how the self-driving cars are trained, they're traveling across the city, they have radars and lidars, and they're like scanning the space around them. And this data is proceeds through the process, through the models, and some outcome is created. Then this data is analyzed. It's analyzed plus the outcomes of the ML model. The mistakes are corrected, and then it goes again and again and again. It's active learning. So for this, the crowdsourcing is widely used because you can, for example, correct the segmentation. And how you can create a segmentation problem for self-driving cars on the crowdsourcing. So you have like your task, which is final result. You want on your pictures from cameras, all objects being highlighted with polygons. And as I said in the beginning, crowdsourcing doesn't work very good on the tasks which are like so big and so, I would say, high level. So how you need to approach that? You're approaching it like this. You're simplifying it. You're saying, okay, we have in a picture, let's mark up every object of every category, road, transport, people, etc. Then, after marking up, how you can control that crowdsourcing doing everything at the high quality level. You're sending it to another project where another part of the crowd says, is there a mistake or not? Was the segmentation performed correctly? Then, if like the final version that everything is correct, you have your markup done at a good quality. I mean, it's not as simple as that, but I would say like high level, it's like this. If it's not, it's getting on the second cycle. And there are like some mechanisms that for not quality ranking, you're not paying even any money. So yeah, you actually managing that you're only, how would you say, encouraging only high quality performance. And yeah, the final result after this simplification, you actually can receive all highlighted polygons like this, for example. That was like the actual project completed on our platform, on Toloka, for self-driving cars. On the left, you can see the result of the highlighting at the beginning, only the one type of a science work highlighted. And then that's after correction with the crowdsourcing on the right. So yeah, for example, if you will ever approach the problem of self-driving cars or the object recognition on streets, which can be done easily because it's like you won't live with one of the typical projects on crowdsourcing, I can recommend using the following pipeline. So it's like simplifications and rechecking on every level. You use a photo, you're checking does the photo contain a desired object, you then ask people to outline it with the bounding boxes. then you're evaluating the correctness of this evaluation, and after some looping, you have a correct result. The other case, which is here I present very simply, actually it might be much more, I would say, difficult and deep and interesting to do, because voice assistance, as you can imagine, is like, as I was saying, is a very, very like deep field to explore. And there are like several approaches for crowdsourcing that you can use. You can use a speech to text, text to speech, and other tasks. You can try to do recognition tasks. You even can gather a sample data for your assistants. For example, you need to test how good is your assistant working with the child voices, because it's usually a case when, for example, voice assistants are not very good processing the child voices or the voices of people with some problems with the speech. And you can even gather data from the crowd, because you can find performers who can use like basically any type of a performance with any type of a speech. And that's what's great actually about crowdsourcing. You can find any type of the crowd. So really simple case here, it's you need to train your voice assistants to understand hey Alexa, or hey Siri, or hey Alice, or hey, I don't know, I think the voice assistants are basically everywhere. And you're just gathering data through crowdsourcing. So you're just asking people to record it, and then you're asking people to check, was it like correct? Was it like set like you wanna? And then after this simple loop of the two projects, you have tens of thousands of speech recordings saying, "Hello Alexa," boom, you have a training data. Oh, this is my favorite, because I was working for some time, for 2 years, in the advertisement moderation department as a data analyst and ML engineer. And moderation is very reliable on the data labeling, because the rules of advertisement moderation change basically every month. And the context of the world all over us changes every second, I would say. And the one tiny mistake in advertisement placed somewhere might cost company, I would say, like, you can forget about the world's brand awareness and everything. Because, huh? Can I continue?
Да, сейчас подожди, наушники воткну.
Yes, please.
Okay. So yeah. So moderation of the content with the crowdsourcing is a very useful thingy, because you can, with your crowd, monitor model on the production using samples of the algorithms which are of course used in the production, because moderation of the advertisements requires processing millions of advertisements every second, basically. So, of course, you can't fully cover it with crowdsourcing. But yeah, crowdsourcing here uses like a pillar which holds on this ML models working in production, because you can sample some percent of the data which is being processed every day in production. You can introduce humans in the loop. You can, through API, like send the data to the crowdsourcing. It can be processed and corrected. And then, for example, if some context mistakes are made, this can create, for example, an alert. And you can understand that moderation of the content by your current ML model is not performed as good as it should be. So yeah, actually, I even did with our platform in my department such a project, and my particular project was of flagging, categorizing the data with some categories which are really important for placing the content on the platforms online. because the content of the advertisement and the content of the platform should be matched. And the categories were like about 70 of them, which is very hard, and sometimes they are overlapping and everything. And human in the loop was actually quite crucial for training and retraining the models that were working into the production. So summary, I hope I didn't like overtalk it. So all I just wanted to show today that data still is a bottleneck of many related to AI products. So still many places where we need data for a lot of problems, for sustainability, for medicine, for transport, for everything. And still there is no one and known by everybody best practice of gathering and using data. And I am giving you a tool, I'm giving you one of the tools which you can try to use and to approach your data science tasks, and this is crowdsourcing. And it's actually have been used successively in many applications, in the many ML and AI problems, and it's proven that it works, and it works well. So if anybody wants to try to use like Talk as one of the crowdsourcing platforms, like to play around, to create projects and to see how fast is labeling and how quality the labeling is happening, you can use this promo code and try to play around and see how it will help you to gather the data for your ML projects. And if you have any questions, for example, you can text me here or you can join the community where it's like everything about the crowdsourcing science and how is it applied in ML problems. So thank you very much.
So thank you, Evgenia. That was really interesting. So I think as our participants in the hackathon also saw, how do we get the correct data to do the ML problem? So I think your platform definitely can help there. And I think it's a really cool thing what you're doing. That's why we're starting cooperating. So all the information will be in the general channel, and after the hackathon, of course, you will be able to get more information on all of our presenters. So Kuba, as far as I'm concerned, or I know, we have reached the end of presentations, right?
Yes, true. Later in the day, that's possible that Matthias will join with Dali stream. So when that happens, we will post the link in the general chat to Deep Learning Labs stream. So stay tuned. Dali is really fun to use, and yeah, I recommend watching that part of the event also.
That would be great. So if most people miss it, since we don't have it really scheduled, it would be good to record it and maybe post the recording in the channel again.
Yes.
And
this recording also will be posted in minutes.
Excellent. And for the rest, for the participants of the hackathon, you're free to develop your solutions now. And as it was published, we will check with you today at 3 o'clock and at 7 o'clock if somebody has some technical or organizational questions.
Yes, if you still don't have a team, please write to me or write in looking for a team. Like I'm sure we can find people you could cooperate still.
Good. Otherwise, we will also check back tomorrow. When did we say at 10 or 11 on Sunday? Yes, at 10 o'clock. Just check in if somebody needs some additional assistance or questions about the hacks. We will be here to assist you. So that's what ends today's presentation sessions, and the hackers keep coding, right? Maybe even with the help of Codex.
Yeah, good luck.
Good luck, everybody. Have a great day, and hope to see you again soon.